Namaskar. So, in last class we were discussing about the nodal and mesh analysis with the help of Kirchhoff current law and voltage law. Today we will discuss about two more theorems which with respect to AC circuit analysis we will try to understand how we will implement those theorems in AC circuits. So, let us understand the superposition and the source transformation theorem with respect to AC circuit analysis. So, now as AC circuit is also linear, you can utilize the superposition theorem in the same way as you did in case of DC circuits. Now, here the important thing which you have to keep in mind is that the processing of the superposition theorem is little bit different as we did in case of AC circuit, because your source operating frequencies can be different. So, if you have multiple sources connected in the circuit and those sources are having a different frequencies, then the problem will also become interesting and we will see how we will solve those kind of problems with the help of superposition theorem. Whenever we have different voltage or current sources operating at different frequencies, we will see that the value of inductance and capacitance, not the value of inductance and capacitance, while we will say that it is a impedance offered by the inductance and capacitance will be different. So, when we will analyze the circuit with the help of superposition theorem, the total response will be obtained by adding the individual responses which we get from the superposition theorem, and we will convert the response in time domain for the final result. Now, it is important to note here that the responses which we get with the help of superposition theorem cannot be mentioned in the form of phasor, because the frequencies of different sources may be different. So, in that case the phasor form cannot be used for representing the answer. So, rather we will use the time domain as a method to give the answer which we get finally after the circuit analysis. So, now let us understand the superposition theorem with the help of few examples under AC circuit. Now, in this particular example we need to find the value of I naught with the help of superposition theorem. So, I naught is the current which is flowing from voltage source. The voltage source is having magnitude as 20 angle 90 degree, and we also have one current source, that is 5 angle 0. So, let us assume that the total current is composed of two components, I naught dash and I naught double dash, where I naught dash and I naught double dash are the currents because of voltage and current sources separately. So, when you take one source at a time, suppose if you take the voltage source at one time, you will get I naught dash, then you take current source only, then you get I naught double dash. The total response will be the summation of I naught dash and I naught double dash. So, let us first take the voltage source. So, when you take the voltage source, your current source will be open circuited. So, in that case the value which we need to find out is I naught dash, and the modified circuit will be as shown in the figure. Now, the voltage source is 20 angle 90 degree. So, you can conveniently write it as J 20 in complex form. Now, you have the circuit as shown in the figure, in which the capacitor is connected in parallel with the series combination of 8 ohm and 8 ohm resistance and J10 ohm impedance. Now, what we will do? We will first try to find out the total impedance of this particular block. So, let Z is the parallel combination of the J2 minus J2 ohm, that is the inductance, the impedance offered by capacitance, and then the in series with 8 ohm and J10, which is connected in parallel with this capacitance. So, when you solve it, the Z value is minus J2 into 8 plus J10 divided by minus J2 plus 8 plus J10. So, when you simplify, you will get the value of impedance offered by this particular section is 0.25 minus J 2.5. Now, the value of I naught dash you can calculate as J20 is the voltage source divided by 4 minus J2 plus the impedance, that is this particular section will have impedance equal to Z, which we just now calculated. So, we can say the I naught dash is nothing but J20 divided by 4 minus J2 plus, in place of Z you can write 0.25 minus J 2.5, and when you simplify I naught dash you will get as minus 2.353 plus J 2.353. Now, next is you consider the current source and short circuit the voltage source. So, your modified circuit will now be as shown in the figure. Here you have 5 ampere current source back in the circuit and the voltage source is short circuited. Now, in this case we see there are 3 loops. So, what we will do? We will utilize the Kirchhoff voltage law to find out the loop currents. So, for say loop 1 or you can say mesh 1, the equation you can write as 8 plus J10 minus J2 into I1 minus of minus J2 into I2, because I1 I2 are in opposite direction here, and then minus J10 I3 because I3 and I1 are also in opposite direction. So, from mesh 1 we get this equation. For mesh 2, what you get? You get 4 minus J2 minus J2 into I2 minus of minus J2 into I1 because I1 and I2 are in opposite direction. Similarly, minus of minus J2 into I3 because I2 and I3 are opposite in this particular capacitor. So, we get another equation for mesh 2. If you see mesh 3, you can directly say that I3 is nothing but equal to 5 ampere, which is the current source. So, what next you have to do? You put the value of I3 in these two equations. So, it will be simplified as 8 plus 8j into I1 plus J2 into I2 is equal to J50 and J2 I1 plus 4 minus J4 I2 equal to minus J10. So, now you get the two equations and two unknowns I1 and I2. You can represent this equation in matrix form. So, matrix form will contain one left side vector which contains J50 and minus J10 as element, and then we compile the matrix containing the coefficients of I1 and I2, that is 8 plus J8 and J2 and J2 and 4 minus J4, and then the unknown quantities, that is I1 and I2. Now, to solve it, the objective for finding out the solution for this particular equation is to find the value of I naught double dash. So, if you see I naught double dash, it is nothing but minus of I2. So, it means that if we find the value of I2, that is sufficient for the calculation. So, what will be the value of I2? First, we will take the determinant of the matrix. So, determinant of the matrix will come out to be 68, and then the determinant of submatrix which corresponds to the variable I2. So, what you will do? You will simply replace the second column with the vector which is given on the left. So, when you replace, you get the modified determinant as 8 plus J8, J50, J2 and minus J10. So, when you find the value of determinant, you get 180 minus J80. Now, what is the value of I2? I2 will be nothing but delta 2 divided by delta. So, when you simplify, you get again the value of I2 as 2.647 minus J 1.176 ampere. Now, as you know that I2 I naught double dash is nothing but minus of I2. So, this will be now minus 2.647 plus J 1.176 ampere. Now, the I2 value will be I naught dash plus I naught double dash. I naught dash we found here, that is minus 2.353 plus J 2.353, and you also got the value of I naught double dash. Then when you sum up, you get the value of final current I naught, that is 6.12 angle 144.78 degree. Now, let us take another example. This example will be really interesting, because here we need to find out the value of V naught using superposition theorem, and if you see this particular circuit, you will have 3 sources and all 3 are operating at a different frequency. So, this is a DC voltage source. So, it means that your frequency is 0. Here you have current source, omega is 5. Here you have voltage source where omega is 2. So, when you have different sources operating at different frequencies, we will utilize the superposition theorem by taking one source at a time and solve the circuit, and finally, we sum up the output, so that we get the final output of the circuit. So, in this case, we need to find out the value of V naught. So, let us assume that V1, V2 and V3 are the individual voltage responses when you take DC, and then the 10 cos 2t volt, and then finally V3 is corresponding to the current source, that is 2 sin 5t taken into the consideration. So, the final voltage will be V naught is equal to V1 plus V2 plus V3. Now, let us take one voltage at a time. First, let us take the DC voltage 5 volt. So, this will be open circuited, this will be short circuited. Now, you have to keep in mind, since we are talking about the DC voltage source, it means that inductor will also be short circuited and capacitor will be open circuited. So, in that case, what will happen? Your modified circuit will look like as shown in the figure. You will left with only the resistances, that is 1 ohm resistance and 4 ohm resistance. So, 1 ohm resistance you got from this particular section, and 4 ohm is from this section where you have capacitor in between, but capacitor will be open circuited and this is short circuit, this is short circuit. So, the complete left to 1 ohm resistance will also be short circuited. So, you will left with only 1 ohm and 4 ohm resistances and 5 volt voltage source. Now, what we have to do? We need to find out the voltage across 1 ohm resistance. So, what we can do? We can utilize the voltage division. So, here the direction of voltage is opposite. So, what we will say? We will say this is minus V1 equal to 1 upon 1 plus 4 into 5 volt. So, minus V1 you get as 1 volt, that is V1 is equal to minus 1 volt. Now, the second case is that in case of V2 we will set 5 volt DC source and the 2 sin 5t current source 0. So, that means if you see the figure, this is 0 and this is again 0. So, now this will be short circuited, this will be open circuited. So, in that case what will be the modified circuit? You will have 4 ohm resistance in parallel with now the capacitor, and the inductor and resistance will be in series, that is 1 ohm resistance in series with the inductance. So, the next task what we have to do, if you remember in case of the nodal and mesh analysis we discussed that first the elements need to be converted into frequency domain. So, to analyze this particular circuit we will first transform the circuit into frequency domain. So, 10 cos 2t we can write simply as 10 angle 0, where omega is 2 radian. So, the 2 Henry inductance will be converted into frequency domain. So, you can write it as J4, and then the 0.1 farad capacitor can be written as 1 upon j omega c. So, it will come out to be minus J5. Now, your circuit is ready for the analysis. We need to find out the voltage V2 across 1 ohm resistance. Now, since these two elements are in parallel, so you can take the parallel combination of these two elements and you can find out the impedance. So, what is the impedance Z? So, in this case minus J5 in parallel with 4. So, when you solve you get the impedance as 2.439 minus J 1.951. Now, you have found this value, we need to find out the voltage across 1 ohm resistance. So, you can simply utilize the voltage division method and find the value of voltage V2. So, what will be the voltage V2? That is the voltage source value, that is 10 angle 0 divided by 1 is the voltage across 1 ohm resistance we need to find. So, 1 will be in numerator divided by the 1 ohm plus J4 plus the parallel combination of the resistance and capacitance. So, we found the value of Z. So, we place the value of Z here and simplify, then we get the value of V2 as 2.498 angle minus 30.79 volt. Now, this you have got in phasor form. Next task is that you need to convert it back into time domain. So, if you convert it into time domain, what you will write? V2 is nothing but 2.498 cos 2t minus 30.79 degree. We get 2t because the original source was having frequency of omega is equal to 2. So, the current will be 2.498 cos 2t minus 30.79 degree, that is the voltage across the 1 ohm resistance, that is V2 will be 2.498 cos 2t minus 30.79 degree volt. Now, the third one is the current source. So, we need to find out the value of V3 when the 5 volt DC and 10 cos 2t voltage sources are set to 0. It means that both of them will be short circuited. So, your modified circuit will look like shown in the figure, where the current source will now be in parallel with the inductance, then we have 1 ohm resistance and in series with parallel combination of the minus J2 impedance offered by capacitance and 4 ohm resistance. Now, first task is that again we have to transform this into frequency domain. So, we will convert it into frequency domain. The given signal, that is given current source is 2 sin 5t. Now, if you convert into phasor, what you can write? 2 angle minus 90 degree, because sine you have to first convert into cos to convert it into phasor form. So, what you can write? 2 sin 5t, you can write 2 sin cos 5t minus 90 degree. So, when you convert it into phasor, it will become 2 angle minus 90 degree. Here omega is now 5 radian per second. So, you have to convert again all the inductance and capacitances into frequency domain. So, 2 Henry inductance will now become J10 ohm as an impedance. 0.1 farad capacitance will offer minus J2 ohm as an impedance. So, we get now the modified circuit where you have J10 ohm as impedance offered by inductance and minus J2 ohm as the impedance offered by capacitance. Then what we have to find is the voltage across 1 ohm resistance. So, that is V3 which we have to find. So, first what we have to do, we have to first take these two the parallel combinations and simplify it. So, when you take these two, we let us say the effective impedance is Z1, where minus J2 is in parallel with 4 ohm resistance. So, you get effective impedance as 0.8 minus J 1.6. So, this you have got. Now, we utilize the current division to find the value of current flowing through 1 ohm resistance. So, here if you apply current division, then you can say that the current is nothing but 2 angle minus 90 degree into 10 divided by 1 plus Z1 plus 10. So, the current I1 which is flowing through 1 ohm resistance, that is I1 equal to J10 divided by 1 plus J10 plus the value of Z1, that is 0.8 minus J 1.6, and then multiplied by current source, that is 2 angle minus 90 degree. So, when you simplify, you get the value of current I1. Now, what is the value of V3? V3 is nothing but I1 into R is 1. So, you get the value of V3 as 2.328 angle minus 80 degree. So, now this is again in phasor, we will convert it into time domain. So, when you convert it into time domain, it will become 2.328 cos 5t minus 80, or you can again convert it back into sine, because sine was the initial value when you saw the current source. The current was written in terms of sine 5t. So, we will convert it back into sine. So, it will become 2.328 into sine 5t plus 10 degree, because cos 5t minus 80 degree can be written as sine 90 plus 5t minus 80 degree. So, this will be simplified to 2.328 sine 5t plus 10 degree. Now, the total response V naught you can write V1, that is minus 1, plus V2, that is 2.498 cos 2t minus 30.79 degree, plus V3, that is 2.328 sine 5t plus 10 degree. So, now you can see that superposition theorem works well when you have voltage or current sources connected to the circuit and having the different frequencies. Now, let us talk about the source transformation. Now, in case of source transformation, in frequency domain, the source transformation involves the transforming a voltage source in series with impedance to a current source in parallel with impedance, or vice versa. That means, if you have current source in parallel with impedance, can be converted into voltage source in series with an impedance. How we will express them? We will express it as Vs. So, this is voltage source in series with Zs, that is impedance. So, Vs is nothing but Zs Is. Equally, it can be represented as Is, where Is is nothing but Vs upon Zs, and then in parallel with impedance Zs. So, you can transform the voltage source in series with impedance to a current source in parallel with impedance as shown in the figure. So, we will utilize this concept to solve the circuit. So, let us take one example. We need to find out the value of Vx using source transformation. So, in this case, how we will carry out the source transformation? You see that you have voltage source 20 angle minus 90 degree connected in series with 5 ohm. So, this particular segment you can utilize to convert into equivalent current source in parallel with resistance. So, how you can write? So, this can be converted into one Is, that is current source. So, what will be the value of current source? Current source will become 20 angle minus 90 degree divided by 5, that is the resistance. So, it will become 4 angle minus 90 degree, or in complex form you can write Is is equal to minus J 4 ampere, and this current source will be in parallel with 5 ohm resistance. Now, if you see the circuit, these two legs are in parallel. So, you can further simplify, then the parallel combination of 5 and 3 plus J 4 will be simplified to say Z 1. So, the value of Z 1 is 2.5 plus J 1.25. Now, again this is converted into equivalent impedance. So, if you see that the equivalent impedance is Z 1 connected in parallel. So, you can say again the current source is now in parallel with one impedance. So, you can convert it back into a current a voltage source in series with impedance. So, what will be the value of voltage source in that case? The value of voltage source will be Is into Z 1. So, now the voltage source you can write Vs is nothing but Is into the value of Z 1 which you have calculated, that is 2.5 plus J 1.25 multiplied by Is, that is minus J 4. So, finally, you get the value of Vs, that is 5 minus J 10, and now this will be in series with the impedance, that is Z 1. Now, if you see this circuit, it is much simplified and you can easily find out the value of Vx. So, what is the value of Vx in this case? You will simply utilize the voltage division. You can say Vx is nothing but 10 divided by the elements which are connected in series now, 10 plus 2.5 plus J 1.25 plus 4 minus J 13 multiplied by the Vs, that is voltage source, 5 minus J 10. When you simplify, you get the value of Vx. So, now you can say that by successive implementation of source transformation in the circuit, you can simplify the network and find the value of Vx very easily. So, with this we can close our today's session, in which we discussed about the source transformation as well as superposition theorem. In next session, we will discuss about two more important theorems which we discuss in case of DC circuit, that are your Thevenin's and Norton's theorem. We will discuss when we consider the AC circuit for the analysis. Thank you.